What's up everyone, welcome back. Patrick here, moving on to the next video dealing with domain range, figuring out whether relations are functions or not. So a continuation of the previous video where we're given a bunch of algebraic expressions and we have to work with these relations here. Again, as I mentioned in the previous video, I'm assuming you have a background knowledge from grade 11 functions when we're going through these. Again, in a few sections, we're going to be dealing with transformations of lots of these functions. And so we will go into more detail, but this is kind of just a warm-up. So as we go along, I'll try to explain characteristics from grade 11 functions as quickly as possible. But this is a video more focused on finding the actual domain and range from these expressions. So first one, we got y equals 1 over x minus 4. So if you notice, this is a rational function. So if you remember the parent function 1 over x, it gets transformed into this function right here. And actually in a few units, we're going to be there's going to be a whole unit on rational functions. And there's going to be a lot of rational functions that you haven't seen before because these get a lot more complex than just taking this base function and transforming it. But in grade 11, that's what you did. And that's what's going to be the focus of this particular unit. And then once we get to that actual rational functions unit, they get more complex. But if you remember from grade 11, remember the d value, that's always going to be what? The vertical asymptote of a rational function 1 over x that gets transformed. And then the c value here, y equals c, that's always going to be the horizontal asymptote. And that's going to be super important for finding the domain and range. So notice in this case, the vertical asymptote is happening at an x value of 4. Another way to think about it is basically what x value is making the denominator equal to 0 because you can't divide by 0. And so the function is going to be undefined there. And then there's a horizontal asymptote at the c value where, well, there is a imaginary y equals 0 there, right? A c value of 0. So y equals 0 is going to be the horizontal asymptote in this case. Now the function 1 over x, the parent function, let's draw it in a different color here. If you remember the way it looks like this, right? It has a vertical asymptote at 0 and it has a horizontal asymptote at 0, right? Because that c value is 0 as well. Well, 1 over x minus 4, the way you could think about it is, remember what does the d value do? It shifts the function 4 units to the right. And so basically that vertical asymptote at 0 gets shifted 4 units to the right. Well, now that means that the vertical asymptote is going to happen at an x value of 4. And we got that over here just from looking at the function, knowing that the d value is the vertical asymptote. So there's multiple ways you can think about this and come up with the function. So those are two different ways, just looking at the d value or the x value that makes the denominator equal to 0. That's going to be the vertical asymptote. Or you could think about taking 1 over x and then shifting it 4 units to the right. Okay, and so the way that the function is going to look is basically like that. The horizontal asymptote stays at 0 because the function wasn't shifted up or down. If it was shifted up or down, that would change the horizontal asymptote. Okay, so from here, well, what's the domain going to be? Well, notice that it could be any x value except that x value of 4. Right? At that x value of 4, the function is undefined. So we would say the domain is x can be anything, any real number, such that x cannot equal 4. Now in interval notation, it's a little bit more tricky. There's actually 2 intervals. So notice that there's this part of the function, which is going to go from negative infinity to positive 4, but not including the positive 4. Or it's going to be this part of the function, which is going to go from 4 to positive infinity, like that. So in interval notation, we have to state the domain in 2 intervals for both of these parts of the function. right? So this is in set notation right here, and then this is the domain in interval notation. And now what about the range? So remember the range, we are looking at the y values. And so if you look at this graph, basically all of the y values are getting touched at some point from negative infinity to positive infinity, except for which y value? The horizontal asymptote of 0, right? That y value, the function never touches that y value. So it's basically going to be YER, but y cannot equal 0, like that. And then for the interval notation, again, we got to look at both of these separately. So this portion of this graph, it's the y values from negative infinity to 0. So we would say from negative infinity to 0, or the union symbol, this portion of the graph, it's all the y values from 0, not including the 0, all the way, and this keeps going up, right, to positive infinity. So it's going to be from 0 to positive infinity. Right, remember the range, you always read from bottom to top, like that. Right, so that's the domain and range. And actually, just in general, I think this will be useful for you to write down for 1 over x in particular. And again, going to mention this in a few sections anyway, but a little repetition doesn't hurt. Just in general, the domain for a transformed 1 over x function, it's always going to be XER. X cannot equal the vertical asymptote, which is the d value of that transformation format that I had before. And then the range, it's always going to be YER. Y cannot equal the horizontal asymptote, which is the c value. Okay, that's always going to be the format of the domain and range for a transformed 1 over x graph. And as I mentioned, in a future chapter, we're going to get into more complex rational functions where this is not going to hold anymore, this format for the domain and range, but this general format does hold for a transformed 1 over x graph, so you can keep that in mind. And then, is this a function or not? Well, yes it is. It is passing the vertical line test everywhere, right? There's no pairs of points that share the same x value, so we would say that this is a function. Now moving on to part B, we got y equals 3 sine x plus 1. So notice that this is a sinusoidal function where we have the parent function y equals sine x. And anything that I say about sine x, it also applies to cos x, because if you remember, cos x is just sine x shifted over. So the transformed function for sine x is a sine of k bracket x minus d plus c. Now, if you remember sinusoidal functions, right, they go on forever, basically. Again, unless it's a word problem, maybe the domain is going to be restricted, but this is just going to be a wave that goes on forever, sine x and cos x. And so the domain, the general format for the domain, if you remember, it's just XER, right, for all sinusoidal functions, sine x or cos x. So this function is going to have a domain of XER. It's going to go from negative infinity to positive infinity. However, the range is going to be a little bit more tricky. So the range, just in general, if you remember a sinusoidal function, right? So it's a wave like this. It's going to have a maximum y value, and it's also going to have a minimum y value. So just in general, and I'll explain in a sec how to get this min and max, just in general from a sinusoidal function, and then we will compare it to this. So just in general, the range is always going to be YER, but the y values have to be greater than or equal to the min, less than or equal to the max. Okay, so from here, min to max, like that, right? So the way we could get the min and the max, the min is always going to be the c value, which represents the equation of the axis, minus the absolute value of a, because sometimes this a can be negative. In this case, it's positive, but in case it's negative, we just want to subtract the absolute value of a, or the amplitude, if you remember the terminology. And then to get the max, it's just going to be the c value plus the amplitude, like that, right? So basically, what happens here is the min, it's going to be 1 minus the a value of 3, which is going to be -2. The max value is going to be the c value of 1 plus the amplitude of 3, which is going to be 4, like that, right? And so if we draw, I mean, you could just write the range just with that, right? But if you wanted to see a visual of this, basically the way it would look like is, okay, we'd be at the axis at 1, we'd have a maximum at 4, and then we'd have a minimum at -2, right? And so it's basically like this, right? And so that's how it's going to look, and it's going to keep going forever. Okay, so the range, basically, well, we can just, let's actually just erase this. I could just plug it in, right, for the max and the min. So the min is going to be what? The min is going to be -2, and then the max is going to be 4, like that, right? And so the range is going to be from -2 to +4, including those, right? Because it's including those points. So we would put square brackets like that. And then is this a function? Yes. Sine x, cos x, no matter how they're transformed, they're always functions. They always pass the vertical line test. So this indeed is a function. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. And then moving on to part C, we have the relation x equals y squared. So this is a funny looking relation. Now, whenever you see something like this happening where you have x to the power of 1, where you have this combination of just x on its own and a y squared like that, it's always going to be a sideways parabola, if you want to keep that in mind, right? So if you think about it, y equals x squared, that's basically a normal parabola. So if we switch these and we have x equals y squared, that's going to be a sideways parabola. And so what you could do is you can make a table of values, and usually for a regular parabola y equals x squared, what's happening is we plug in the x values, usually like -2, -1, 0, 1, and 2, and then plug it in into x squared to get the y values. Well, for these, I like to do the opposite, right? Because we know that x is equal to y squared. It's dependent on the y squared, so I like to plug in values for y like this, and then plug it in here to get the x values, which is going to be 4, 1, 0, 1, and 4. And so if we graph these points here, we would have 0 and 0, 1 and 1, 1 and -1, which is going to be like here. And then we're going to have 4, x value of 4, y value of 2, y value of -2. And so the graph is looking like this. All right, so you could plug in y values and then get your corresponding x values when you see this happening. All right, so just be on the lookout for these. When you have an x and you have a y squared, any kind of combination of them, it's going to end up being a sideways parabola. And so from here, well, what's the domain going to be? Well, notice it is all of the x values, but the x values have to be greater than or equal to 0, right? That is the minimum x value of 0. There's no x values over here. So in interval notation, we would say it's from 0 to infinity, and it's including that 0, so we put a square bracket there. Now, what about the range? Well, notice at the range, there's no limit on the y values, right? They're going from negative infinity to positive infinity, right? Because this keeps extending both up and down infinitely. So basically, all of the y values are getting hit at some point. And so the range is just going to be YER, or we could say an interval notation from negative infinity to positive infinity. And then is this a function or not? Well, notice it is failing the vertical line test everywhere. Okay, a sideways parabola is never a function, so this is not a function. And then finally, moving on to part D. So notice here, again, like in part C, we have this combination of x and a y squared, right? X to the power of 1 and a y squared over here. It's in a different format, but nevertheless, that combination of x to the power of 1 and y squared is here. So we know this is going to be a sideways parabola. Question is, how is this going to look? Because there's a lot more going on over here. So again, what I like to do, get the x by itself. So I'm going to bring the 3y squared over. So I'll have negative 3y squared minus 1, like this. And then you can make a table of values and see how is that x value going to behave for certain y values if we plug in y values. So we could plug in negative 2, negative 1, 0, 1, and 2. So if I plug in negative 2 here for y, that'll be 4 times negative 3, which is going to be negative 12 minus 1, negative 13. If I plug in negative 1, and actually it's going to be symmetrical, right? Because negative 2 squared or positive 2 squared, that's going to give you 4 right here. So you're going to get a x value of negative 13 as well for a y value of 2. If I plug in a y value negative 1 squared is positive 1, times negative 3 is negative 3, minus 1 is negative 4. I know it's going to be symmetrical, so that's going to give me that x value of negative 4 as well. If I plug in a y value of 0, 0 squared, 0 times negative 3 is 0, minus 1, so we'll have minus 1 like that for the x value at y value of 0. So if we plot this, let's see how this is going to look. So we got negative 1 and 0. That's going to be right here. And then we have negative 4, x value of negative 4. That's over here. And then we have a y value of negative 1 and positive 1. So that's going to be up here and up here. And then we got negative 13. So we're going to have 2 and negative 2. So it's going to look like that, right? So, yeah, another sideways parabola. So what's going to be the domain in this case? Well, notice now it's going the other way, so the maximum x value is going to be negative 1, right? So the x values are going to go from negative infinity to this maximum of negative 1. So we would say x can be any real number as long as x is less than or equal to negative 1. Okay, for interval notation, remember, we read from left to right, so negative infinity to negative 1. We would say negative infinity to negative 1. It's including the negative 1, so we put a square bracket there. And then for the range, same thing as the previous one. There is no limit on the y values, right? From negative infinity to positive infinity. This keeps extending down, this keeps extending up. So basically all the y values at some point are going to get hit on this relation. So we would say the range is just going to be YER, or an interval notation from negative infinity to positive infinity, like that. And then is this a function? No, right? Failing the vertical line test pretty much everywhere except this x value of negative 1. But again, it only has to fail once for it not to be a function. But it's basically failing it everywhere. So no, sideways parabola is never a function. All right, so that's pretty much it for these algebraic expressions. Again, in the future chapters, in future sections, in a few sections, we're going to go over transformations. We're going to go into more detail, but this is just sort of a quick warm-up with a little bit of review from grade 11. functions. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.